There's something out there in the cold, dark expanses of space that is far more terrifying than a black hole. It's a dead star that's somehow even more deadly than a black hole. In this video, we're going to tell you all about these bizarre objects. How do they compare to black holes? And why do some scientists say they're scarier? Let's get started. What is a gravastar? First off, let's answer the most important question. What the heck is a gravastar? The name comes from gravitational vacuum star, and that tells us pretty much everything we need to know. While a neutron star is basically a regular star that has collapsed under its own gravity, a gravastar is a star that has collapsed into a kind of shell or bubble, but instead of matter, it's filled with a vacuum of dark energy. Scientists think that at its core, a gravastar would contain a thin shell made of dark energy, but what lies inside that shell is unknown. It could be nothing, or maybe there'd be some regular matter or even dark matter. What we do know is that the inner space would be entirely cut off from the rest of the universe. Even light couldn't escape, not because of any event horizon, but because the dark energy creates a kind of barrier that prevents anything from getting through. That means if you fell into a gravastar, you wouldn't see anything. You'd just keep falling forever. However, instead of disappearing into a singularity, you'd reach a wall. Then what would happen after that? Nobody knows for sure. Some physicists have suggested that the energy from matter falling into a gravastar would simply be stored up inside the shell, meaning that the gravastar would grow larger. But others disagree, saying that any object hitting the shell would pass straight through into the void beyond. There's so much we don't know about how a gravastar would react to incoming matter. We can only speculate. Differences between gravastars and black holes. Now that we know what a gravastar is, let's compare it to something similar, a black hole. These two objects look identical on the outside. Both have an event horizon marking the boundary beyond which nothing can escape. And both will consume anything that gets too close. But they work in completely different ways. The key difference is that a black hole is all about gravity. As a star collapses, its mass is concentrated into a smaller and smaller space, creating a powerful gravitational field. Eventually, the gravity becomes so strong, not even light can escape. On the other hand, a gravastar doesn't rely on gravity. Its defining feature is the dark energy bubble inside. While gravity can pull matter toward a gravastar, it can't pull it through the energy barrier. This means that once something crosses the boundary of a gravastar, it's gone forever. Nothing can get out. But that's not necessarily true of black holes. According to quantum physics, nothing is truly gone until it's completely dispersed and can't be recovered. Some physicists believe that when matter falls into a black hole, it doesn't disappear, but is instead transformed into a different state of matter. That means some information about the original object is preserved. In theory, that information could eventually leak out of the black hole and reveal what happened to the object. That process would take a very long time though, and we've never observed it happening. So while the information paradox isn't settled, we can safely say that black holes retain more information about what went into them compared to gravastars. Why are gravastars scarier than black holes? So if black holes actually do preserve information about what goes into them, why are gravastars considered scarier? Well, it all comes down to stability. Black holes are incredibly stable and can exist for trillions of years. All that stuff trapped inside struggles against the intense gravity and eventually releases some of its energy as Hawking radiation. That keeps the black hole from being perfectly stable, and it slowly evaporates over time. Gravastars, however, might be much more stable than black holes. Their insides aren't affected by gravity, so there's nothing that can push back against the dark energy bubble. That means a gravastar might last for billions of times longer than a black hole. Also, since we don't know exactly what's inside the bubble, we don't know what kind of energy it contains. But the fact that a gravastar is even capable of forming suggests that whatever is inside must make up a huge fraction of the star's total mass. That means a gravastar might be a massive reservoir of dark energy, distorting spacetime around it in ways that we can't even imagine. Not only that, but gravastars might be much more dangerous to life than black holes. Some researchers have suggested that if two of them collide, they could send out gigantic gravitational wave signals unlike anything we've ever seen from black holes. Such waves could literally tear apart entire planetary systems. While black holes might seem scarier, gravastars could be much more destructive. Scientific evidence and theories. Now that we know what gravastars are and why some scientists find them scarier than black holes, let's talk about evidence. Remember, gravastars are still purely hypothetical. We've never directly observed one, and there's no guarantee that they even exist. Otherwise, they should be quite easy to spot. Just look for stars without any light coming from their insides. That's one of the key differences between a gravastar and a white dwarf, which is a star that has used up all of its nuclear fuel and collapsed. White dwarfs glow brightly at first, but quickly cool down. Meanwhile, a gravastar would be completely dark. Unfortunately, we haven't found any dead stars that fit that description. One interesting possibility is that the signals we VA detected from merging black holes could have come from colliding gravastars. After all, they'd produce gravitational waves in a different pattern than black holes. But until we can spot actual gravastars, we won't know for sure. Some physicists argue that gravastars could help solve the information paradox we mentioned earlier. That's the problem of reconciling quantum mechanics with general relativity. According to quantum physics, nothing is truly destroyed. Every object retains some information about its past. But according to Einstein's theory of general relativity, once something crosses the event horizon of a black hole, it's gone forever. Some scientists think that gravastars might offer a compromise by allowing some information to leak out of the star, but only if that information was encoded on the surface of the object that fell in. That could mean that the surface of an object carries more information than its bulk, which has all kinds of implications for physics, chemistry, and computer science. Gravastars might also help us understand how stars die and transform. When a star runs out of nuclear fuel, it collapses under its own gravity. The outer layers fall inward, toward the dense core, which gets hotter and hotter. Eventually, the heat and pressure at the core becomes so extreme that protons and electrons are forced together to form neutrons. That forms a neutron star. But some scientists suggest that if the star is massive enough, the core could collapse all the way through to the other side, emerging as a gravastar. Others claim that a collapsing star would form a black hole before it could ever become a gravastar. Those physicists are still debating the issue. Cosmological implications. Finally, let's discuss some of the cosmological implications of gravastars. For starters, if they exist, they could explain some of the features we see in distant supernova. When a star explodes as a supernova, it leaves behind either a neutron star or a black hole. But some supernovas seem to leave behind objects that are neither. Those objects have masses similar to neutron stars, but they don't emit any light. Gravastars could explain what those objects are. Also, the study of gravastars overlaps with the mystery of dark energy. That mysterious force makes up 68% of the entire universe. It's everywhere, but we don't know what it is. We only know its effects. Right now, the leading explanation is that dark energy is a property of space itself, similar to how gravity is a property of mass. This means that empty space has some kind of intrinsic energy. Some physicists think that dark energy is related to the vacuum expectation value of quantum fields. The idea is that even empty space has some quantum fluctuations. Those fluctuations create tiny particles that pop in and out of existence. The presence of those particles gives rise to dark energy. If that's right, then a shell of dark energy could theoretically trap those particles inside. And that could explain a gravastar. The trouble is, we don't have any evidence for that theory. It's pure speculation at this point. Is the true cosmic reaper the black hole or the gravastar? Now that you know all about gravastars, it's time to answer the ultimate question. Which is the true cosmic reaper, the black hole or the gravastar? Well, the answer depends on your definition of scary. If you're worried about information loss, then go with the black hole. It's the proven monster that swallows everything and spits out nothing. But if you're more concerned about stability, then the gravastar is the clear winner. Since we don't know exactly what's inside a gravastar, we can't say for sure how long it will last. But its inner darkness makes it a more stable place than a black hole. And unlike a black hole, it might leave behind some clues about the nature of reality. Ultimately, both objects are fascinating in their own ways. Black holes are the monsters of myth and legend, while gravastars are the ultimate unknown. We may never be able to observe one, but the search will take us to some amazing places. Now check out amazing black hole facts that will blow your mind. Or watch. What happens to time around a black hole?